Hello everyone, welcome to Ask Geology, a whole new way to understand our Mother Earth. Okay, in this today's 7-minute numerical, we'll be discussing about one numerical related to geophysics, but not purely geophysics because this is a jam question. You can see that this is yellow banner. This yellow banner represents from your jam. Okay, if it is blue, okay, then that is from gate, and if it is green, that is from CSIR net. Okay, and if it is further blue, then that is from our ask geology group questions. Okay, so this is basically simple refraction, okay, using the Snell's law, and that Snell's law is basically that is also obeyed in case of P and S wave. Okay, though these are P and S wave velocity they have given, that's why I have just included in the geophysics series. Okay, so question is given: a P ray arrives at the mantle core boundary at an angle 25 degree with respect to the normal. Okay, you can see this is the normal. At what angle to the normal does it enter the core? Okay, now they have given that this theta 1 to be 25 degree. Okay, theta 1 is to be 25 degree to with the normal. Now they are asking about this theta 2. Okay, what will be the at what angle in degree, at what angle to the normal? You can see that this is the normal, so from this angle you have to calculate. Okay, in Snell's law you know that whatever the degree measurement, okay, the angle of incidence or angle of refraction, they are measured from the normal. Okay, you just don't write down this one, this is not from the normal, you have to measure the angle. Okay, so the P wave arrives at the mantle core boundary at an angle of 25 degree with respect to the normal. At what angle the normal does it enter the core? Okay, given that P wave velocity in the lower mantle 13.7 and outer core. Okay, if it is the core mantle boundary, okay, if this is the core mantle boundary, that is basically 2900 kilometer. Okay, that is your Gutenberg Iit-Jam discontinuity. Okay, that is the core mantle boundary. So this is the lower mantle and this is the outer core. So what are the velocity given? Here the lower mantle v1 is given to be 13.7 kilometer per second, and in the v2 it is given to be 8.1 kilometer per second. Okay, so Snell's law we know that is, okay, this sine I, this is I is sine I by sine R is equal to v1 by v2. Okay, this is v1 is the this one velocity in the upper layer, and v2 that is the velocity in the lower layer, and I is the angle of incidence. Okay, and R is the angle of refraction. Okay, so we have the values. What is the sine I value? That is given to be 25 degree. Okay, in the upper mantle you can see that, okay, core at an angle of 25 degree with respect to the normal at the core mantle boundary. Okay, divided by sine R, this R we have to calculate, is equal to v1 what is given 13.7 divided by 8.1. okay, kilometer per second, they will cancel out. So here we can say that this sine R is equal to sine 25 degree into 8.1 divided by 13.7, isn't it? And this, you just calculate the value. Okay, this is equal to your 0.24986 और भी values हैं. Then R, what is the value of R, is equal to sine inverse 0.24986. okay, and this value we just get it to be 14.46 degree. okay, this R is your one type of angle, and this is your answer. Okay, so and in the IIT-Jam, whatever the virtual calculator is given, you just make yourself familiar with that, because this inverts and types of if you have to calculate a long range calculation. Okay, if there are so many addition, subtraction, minus, okay, inverse, you just make yourself familiar. Okay, otherwise you will get in trouble during the exam. So what is the answer? 14.46 is your answer. Okay, so in this is I have just used, because he has given that the core mental boundary, whatever the, okay, so you just see that this is the internal structure of earth. Okay, there are so many of layers. This is Sial, Sima, okay, then that is the Moho, that is Moho is the core crust and mantle boundary, Moho. Okay, Gutenberg, this is the mantle and core, 2900 kilometer, you can see. Okay, in the Lehman discontinuity, inner core and outer core discontinuity 5150 kilometer, 5200 kilometer, that is the Engleman discontinuity. Okay, these are the pressure at the core mantle boundary. Pressure is around 136, okay, 329 GPa gigapascal, and at the center of earth the pressure is 364 gigapascal. And what is the radius? That is the 6371 kilometer, that is the average radius. You can see what is the gravity value at the core, or the at the center of the earth. The gravity value is 0. Then core mantle boundary gravity value 10.7, 9.8, okay, 9.8 on the surface of earth, or 10 gram per cc, they just calculate. Then if you just go, then that also decreases. Okay, you can see that 10.7 the gravity value, g value, acceleration due to gravity, that is maximum in 10.7. okay, so and you can see the thickness and density. If this crust and mantle, what actually happen at the boundary of crust and mantle? Velocity increasing, density also increasing. But in case of the mantle and core, the velocity is decreasing and density is increasing. Okay, so we just call it one inversion boundary. Okay, so then after that, this is basically representing the value of your p wave velocity. Okay, you can see that p wave velocity is increasing. Okay, at this core mantle bound, sorry, at this core mantle boundary, it is decreasing from 13.7 to 8.1. Okay, it is the value given in the question also. So these are very important. And you can see that the outer core has a maximum thickness as compared to all those. Okay, and you can see that the various types of aluminous phases. Okay, plagioclase is dominant below 50 kilometer, then that changes to spinel is more stable, around 50 to 80 kilometer. Garnet is stable around 80 to 400 kilometer, and above 400 kilometer, that silicon becomes, okay, and the silicon stays in six-fold coordination number. Okay, these are types of, like, plagioclase is stable on the very shallower, then spinel, then garnet. Okay, and you can see that there is one mineral. Okay, there are various types of transitions. Okay, you can see spinel, olivine, then spinel, olivine to spinel, then ringudite, then ringudite to perovskite. And this perovskite is basically the dominant mineral phase present in the mantle. Okay, so these are the elemental abundance of your elemental abundance of different reservoirs in universe. You can see hydrogen, helium, oxygen. Okay, in the earth, FeOCs, silicon, magnesium, nickel. Okay, in crust you can see OC alpha magicana. Okay, OC alpha magicana. Okay, OC alpha magicana. Crust you have to remember. Okay, this is very important. Then in the atmosphere, nitrogen, oxygen, carbon dioxide, argon, moon, oxygen, silicon. These are the elemental abundance of in various types of sources. Okay, in the low velocity zone, there is one low velocity zone. Low velocity zone shows a reduction in the velocity about 3 to 6%. Okay, of the effect being more pronounced with S wave compared to P. Okay, for low velocity zone to occur, water or carbon dioxide must be present to cause partial melting. Okay, due to this partial melting, or due to the change in the phase, there is a low velocity zone created. Okay, if this would be very hard, then very hard hoga, तो then there will be no decrease in the velocity of your waves. Okay, if there is partial melting or the state change is there, then they are expected to, or we expect a decrease in velocity. Okay, so in this question our answer is around 14.46. This is more or less general geology question. This is geophysical question, but I have included this general geology part. Okay, this is very much important. And thank you guys. Save our mother earth, plant more trees, make it green. Okay, this is our responsibility. And if you are very much interested to join our group, this is Ask Geology group, you can just simply call, or you can simply text to these numbers, or simply put a mail to this Gmail ID, or simply you just click on the links given in the description box. Thank you.